We have here is I have three of the example problems from homework work last night. That's problem number 5. If you want to pause the video, this was problem number 13. If you want to pause that video, and then over here we have problem 17. But problem 17, I worked it two different ways. I worked it with two different u values. Here I have u equal to the square root of x, and here I have u equal to this numerator before I squared it. So you get the answers look different, but if you took the derivative of both of them, you would come back up with that as the solution. So now we're going to get into differential equations. And if you talk to math and engineering majors, this is one of those, it's a course, and it's a course that's kind of a make or break course for a lot of students. So we're introducing differential equations, and you're going to look at a lot of the different concepts behind it. But differential equations tends to go along the lines of, hey, this may have come from a function or it may not have come from a function, which, if you think about derivatives, that's what implicit differentiation dealt with. You may have been taking a derivative where you had a function, or in the case of when we took implicit differentiation with a circle, then that was not a function, but we could still differentiate this. So some of these will come from functions and some of them won't. Now, on the AP test, when they put this out here, the instructions would usually say use separation of variables to solve this out. So we start off with just this as the equation. We want to know what dy dx is if it's, I'm sorry, they're telling us that dy dx is equal to x plus 1, and we want to know the equation that yields this. So we separate our variables. Now, there are no y terms, so I do just like what I did with my u substitution. I pull this term over to here. So it's dy equals x plus 1 dx. Okay, well, at this point right here, again, we're trying to come up with the parent equation that gives us this, so we want to integrate both sides. In my years of teaching, there's only been 1 year where there was not a differential equation on the AP test. And it's as a free response question. There's probably a differential equation that year on the multiple choice. I didn't get to see the multiple choice questions, but there was probably, but there was not one year there was not one on the AP test. Now I'm throwing out COVID. That year they didn't do differential equations because they stopped. I think they stopped at the basics of antiderivatives, so they didn't get to the differential equation part. Anyway, now what is the antiderivative of dy? Y plus c, correct? All right, now, what is the antiderivative of x plus 1 dx? What's x squared over 2, right? Plus x plus c. Now we want to solve for y, so we subtract c from both sides, right? So what do we end up with? Actually, they don't.
C squared.
C minus C is C.
Okay.
Again, that goes against everything you learned in your math classes up till now. C minus C is C. Now, from here on out, when we do differential equations, I'm not going to show this step right here. I'm going to jump straight from here to here. I think y'all can see why. No pun intended. Ha 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 ha. I know this video is going to go viral. All right. So now, let's look at a different example. Let's go with dy dx equals 4 times the cosine of 2x. Okay. So, again, and you get, on the free response, you get 1 point just for getting this step right. No calculus involved at all. All you're doing is separating your variables. That's 1 point right there. Sometimes it's the easiest point on the test. In the case of this problem here, it would probably be the easiest point on the test. All right, now we want to anti-differentiate both sides. Now, sometimes this next step would be worth 2 points out of 9, but sometimes it's only worth 1 point. It depends on how complex this is. In this case right here, since it's just dy by itself, they wouldn't give you a point for this side. But now we get to the other side. What is the antiderivative of 4 cosine 2x?
Negative sign.
Well, I'm going to let you equal to 2x.
Maybe you sine 2x. I mean 2 sine 2x.
So du is going to equal to what?
2.
2 dx?
Yeah.
Okay. So du over 2 equals dx. So again, the constant I can pull out front. So it's 4 over 2 times the integral of the cosine of u du. Is there a question about that? So y equals 2 times, all right, what is the antiderivative of cosine of u? Yeah, positive sign. So it's the sine of u plus c, correct? So at this point, y is going to equal to 2 times the sine of 2x plus c. Yes?
Just ask what cosine is the derivative of, like when you found sine.
Okay. The derivative of sine is cosine. So it's the reverse. Does that make sense? Did I answer your question? Okay. Gotta quit smoking. What is the... any other questions about this one? All right. Now let's get into dy dx equals the square root of x over the square root of y. Okay, so what did we say that the first step would be here? Separate the variables, yeah. So the square root of y dy equals the square root of x dx, and again, what does this become? 1 over 2 square roots of y? No, I meant that's horrible. And I differentiate, and I don't know why I decided I was going to take the derivative there. All right, so this is y to the 1/2, right? So it'd be y to the 3/2 times 2/3, right? Equals x to the 3/2 with the 2/3 plus a constant. Are we okay here?
But if you said before that dy equals y, then why wouldn't you have an extra y? I mean, it's just times one.
What is the derivative of y? 1. What is the derivative of 2/3 y to the 3/2? If I took the derivative of that, it would be y to the, and then 3/2 minus 1 is 1/2, right? So if I stuck an extra y in there, it wouldn't be its derivative. Or, I'm sorry, if I stuck an extra y in there, it wouldn't be its antiderivative. So, also think about what happened. When I took just the antiderivative of dy, it was y. Well, how many y's do I have in here? This is horrible arithmetic, but follow the concept. I add 1 y to that, right? And I get y. Well, what happens when I add 1 y to the square root of y? I get y to the 3/2. So I am adding a y in there. It just looks different. Does that make sense?
Yeah.
Okay. Okay, now I'm trying to solve for y, right? So how do I solve for y? Well, let me multiply both sides by 3/2. So y to the 3/2 equals, all right, what's 3/2 times 2/3 x cubed? X to the 3/2. And what's 2/3 times a constant? So are we still okay here? All right. Now, I want to raise both sides to the 2/3 power. That way y will be by itself. So this becomes y equals x to the 3/2 plus c, and it's to the 2/3 power. Now, at this point right here, I'll leave that c alone. I don't say, oh, okay, well, I can distribute the 2/3. You don't distribute an exponent into a binomial like that. So I just leave it as this binomial to a power.